So now we're going to start talking about proofs. So when you think about a proof, think that you are the lawyer in the courtroom and you've got to prove that what you're saying is true. You can only use information that has already been entered into evidence. So for us, this is the given. We are given that 4p plus 15 equals 7p minus 3. So we're going to apply our algebra skills to solving this equation, and we're going to list our reason for every step. It seems a little tedious, but it's good practice to get us ready for a real proof. So maybe to solve this one, I'm first going to subtract 4p from both sides. And that's going to give me 15 equals 3p minus 3. I just did the subtraction property. Remember, you had all the properties listed on the front page of your notes. Next, I'm going to add 3 to both sides. So that means I just did the addition property. And in my final step, I'm going to divide both sides by 3 to get p equals 6, my answer. And I just did the division property. I understand that it's a little tedious, but we're going to solve our equations and explain every step we did. It'll come in handy down the road. All right, for the next equation, I'm going to start right here with the distributive property. So we write, I did the distributive property. So I'm not going to write down the step I did, I'm just going to write the result and give you a minute to see if you can tell what property I just used. How did 5d suddenly become 1d? If you're thinking, you did the subtraction property, because I subtracted 4d from both sides, you'd be correct. So my next line, I'm going to write d equals negative 5. And you might ask, how did I get that? Where'd that 17 go? Why did 12 become negative 5? Oh, you subtracted 17 from both sides. So once again, I did the subtraction property. Be careful, if you abbreviate subtraction as SUB, we might get confused with the substitution property. So it's okay if you want to do this for subtraction property, but just you don't want to confuse it with the substitution property. So on our next page, we're just going to practice some of the postulates, theorems, and properties that we've learned and see if we can identify what they're going to look like when I do a proof. So for example, this one says GFH. So I'm going to find angle GFH. It's right here. And KFH is right here. It says those are supplementary. So we look back at our list of rules and see if we can find something that goes with this. Well, I'm thinking linear pairs are supplementary because those two angles are linear pairs. So I would call that the linear pair postulate. If you forget the name of the rule, you're like, I don't remember what it was called, then just write down what it says. Write down what you remember. Linear pairs are supplementary. How about this one? RS plus ST equals RT. I'm going to call that one segment addition. The little segment plus the little segment equals the big segment. This one says measure of angle WXZ. WXZ is right here. And angle ZXY is right here. Equals the measure of angle WXY. I'm going to go with angle addition. I added 2 small angles to get a bigger angle. All right, number 6 says the measure of angle 1 plus the measure of angle 2 equals 180. This is actually 2 rules wrapped into one. Angle 1 and angle 2 form a linear pair. They're adjacent angles that make a line. So I'm going to go with the linear pair postulate, But the linear pair postulate says that two linear pairs are supplementary. How did we get to where we said they equal 180? Well, what are supplementary angles? Two angles whose sum is 180. So two things happened here. We did the linear pair postulate, and we did the definition of supplementary angles. So this one says angle 1 is congruent to angle 3. So we think back to our rules. What rule tells us that those two angles are congruent? If you're thinking it's the vertical angle theorem, you'd be correct. Vertical angles are congruent. Some people like to call that VAT for vertical angle theorem. I sometimes just write out the statement, vertical angles are congruent. Let's take a look at this one. If EB is perpendicular to CA, then that's going to make angle CBE, that's this one right here, equal to angle ABE, that's this one over here. Well, let's think for a second. What do perpendicular lines do? Let's look back at our definition. Perpendicular lines intersect to form a right angle. So I'm going to say definition of perpendicular. The definition of perpendicular makes those right angles. Well, why can I say they're congruent? Well, don't we have a rule that says all right angles are congruent? So first of all, the fact that they're perpendicular makes them right angles. And then all right angles are congruent because they have the same measure. So I really want you to think when you see a picture what rule, property, definition, or theorem matches that picture, because you're going to have to explain why you're doing what you're doing. So here's an example, a big example of your first geometry proof. It says here that angle 1 and angle 2 are supplements. Angle 1 and angle 4 are supplements. The measure of angle 2 is 45. Prove that angle 4 is 45. So when we start a proof, we basically restate the given. I call this our opening statement. When you're a lawyer in court, you have to make your opening statement. And you say, this is what we've got. We've got the fact that these two angles are supplementary, and the measure of angle 2 is 45 degrees. That's our given. You always start with the given. You don't have to put all of these statements in number 1. I just do. All the given, write it down. You'll always have that step correct. Now we've got to start thinking about what we can do with this. Well, the only thing I can think of is this word supplementary. Remember what supplementary meant? Supplementary meant that the measure of angle 1 plus the measure of angle 2 equals 180. And it means the same thing for angle 1 and angle 4. And now I'm going to go over here and explain what rule did I just use to go from here to here. So we look back at our list. I think I just used the definition of supplementary angles, because I saw the word supplementary and I said, hey, they add up to 180. So I'm going to say definition of supplementary angles, or just abbreviate it, definition of sup. Now, what can I do? They told me that angle 2 was 45 degrees. So I wonder if I could substitute 45 degrees in place of angle 2. Remember, if two things are equal, I can take one out and substitute the other in its place. So I'm going to say angle 1 plus 45 degrees equals 180 degrees. That was substitution. We took something out, we replaced it with something it was equal to. All right. Now, can I say that the measure of angle 1 is 135 degrees? And if I can, what did I just do? I did the subtraction property of equality. where I subtracted the same number from both sides. Now, remember what we're trying to prove? You know how sometimes when you work on a maze, you start at the beginning and then you get to a certain point, then you start at the end and work backwards? So this is the point where I'm going to work backwards. I've got to prove that angle 4 is 45 degrees. Well, right now I know that angle 1 is 135. So I think if I substitute it again, maybe I could prove what I'm trying to get to. You always want to keep your eye on what you're trying to get to. So I'm going to say that angle 1 is 135 degrees plus the measure of angle 4 equals 180. We took this and we put it in place of angle 1. That's substitution. Now notice I used substitution earlier and I just used it again. You can use the same reason or the same property more than one time. Alright, now I think I'm almost done. I am ready to say that the measure of angle 4 is 45 degrees. And what did I just do? Well, I think I subtracted 135 from both sides. So I did the subtraction property again. So just a note, when you are writing a proof, never write the word proof or prove at the end. You always write a definition, a property, or a theorem. So proofs are going to challenge your brain a little bit. You've got to put things in order and you've got to explain your reason for everything. And so far, these are pretty much your reasons that I gave you on the first page of your notes. And we're going to learn more reasons as we go along. So you're going to start by trying these proofs. It's your first shot at it, so it may not be the easiest thing you've ever done, but I want you to try, work together, check a little bit with the answer key. Whatever doesn't make sense, be sure to ask.